Right, so having looked at partial fractions, when we start with a fraction that has distinct linear factors in the denominator, we've also looked at when we have repeated linear factors in the denominator. We're going to look at the third form out of 4 now, which is when we have an irreducible quadratic factor in the denominator. What this basically means is when we have a quadratic on our denominator that we can't actually factorize, in which case it has no real roots. So we basically have to deal with the quadratic part as it is. Okay, so there's a whole separate general form for this, which I'm going to dive straight into. But again, you've just got to remember that the general forms aren't given in the formula sheet. You have to learn these different forms and you have to be able to spot when and where to use them. Okay, so what you're looking for here is on your denominator, basically you have a situation where you can't reduce the quadratic part at all. So a couple of you actually emailed me in the last few with questions about one of the denominators, thinking that you couldn't reduce it. You got to check obviously all your different forms for factorizing. So does it have a common factor? Is it a difference of 2 squares? Can you just factorize it in terms of a trinomial? The point is, as long as you can do all those things, then you can do a combination of the previous 2 that we've learned. If you can't factorize it at all, then you have to follow this general form. Okay. So it's for when the denominator has an irreducible quadratic factor. So it's going to be something like this. So there's basically a part of it that's fine, part of it is linear, and there's part of it that has to remain as a quadratic because we cannot factorize it at all. Okay. So when that is the case, when that is the situation, we basically have to change the numerator. So the first one's fine, just ignore that. That's just the ax plus b part that just goes along as normal. But in terms of the bit that we can't reduce, we've basically got to have the numerator as something x plus or minus something. Okay, the idea is that we basically want the degree to be 1 less. Okay, so the fact that this is staying as x squared means that there has to be an x in terms of the top. It might actually cancel out, okay, because you might work out that b is equal to 0. But we're assuming from the start that there could be an x on the top, right? You might find if you do this, and if you do this by mistake, I had a lot of kids last year that you actually match up the answers very, very similarly. Okay, but what it actually means is there can be infinite results when you do it this way. So if we're tempted to use just b in the fraction, which you might be tempted to do if you've not thought about this, okay, there can be infinite results. You might find the result actually that's very similar to what you're supposed to get. But the SQA are looking for you obviously to do it like this, to start it off like this, in which case, if you don't, you're going to lose marks, okay? So this is what you're looking out for. You're looking out for when you have, in your denominator, you have a quadratic part that can't be reduced any further, in which case the form of your partial fractions, okay, will have a bx plus c on top of the part that's still quadratic, okay? So we'll go through an example with you just now. So something along these lines, we've got 3x squared plus 2x plus 1 on the top, x plus 1 and x squared plus 2x plus 2 on the bottom. Right, ordinarily what you've done for the previous few questions is that you've checked, can you factorize this? Okay, so you can do it in a number of ways. You can actually just go ahead, does it have a common factor? Is it a difference of 2 squares? Can I split it into 2 brackets in terms of a trinomial? No, you can't in this case. You could just obviously use the discriminant. That's an easy way to check that it can be factorized, but I know most of you would just go ahead and try and factorize it. So this one cannot be factorized, okay? In which case we have to obviously use the general form that we've just looked at, okay? So that's what it's going to look like. And as I say, if you just try to split this up into a over x plus 1 plus b over x squared plus 2x plus 2, you might end up with a similar answer. There's a good chance that you won't end up with the right answer though. And obviously this is not how it's done, so you have to have initially started with a bx plus c. Okay, as I say, we're basically looking for the order to be 1 less. So this is x squared order, so it's the degree of the highest part of the denominator, and we want the numerator to be 1 less than that. Okay, so it's x squared here, we've got bx plus c on the top. Right, from here everything just works out exactly the same as before. There's a couple of you, I think, skipping this next stage. I remember a lot of kids did that last year. If you don't think about what you're doing in this next stage, if you just kind of assume what it's going to look like, you'll end up making mistakes. Okay, so actually follow through what you're trying to do here and actually multiply through by the denominator of the left-hand side. Okay, so take your time here, otherwise you're just going to lead to mistakes. Okay, so we're multiplying this by x plus 1 and x squared plus 2x plus 2, in which case on the left-hand side, we're just left with the numerator, but obviously it changes ever so slightly on the right-hand side. Okay. So we multiply this one by x plus 1, the x plus 1 disappears, but we still need to multiply by the x squared plus 2x plus 2, in which case we've got a times by x squared plus 2x plus 2. Right, be careful here. Obviously, we need to introduce a bracket. If you don't, that'll lead to mistakes as well. Okay, it's the whole thing that's multiplied by x squared plus 2x plus 2, which means that we're left with a bx plus 2, but we still need to multiply bx plus c, sorry. Still need to multiply by the x plus 1, in which case it's bx plus c times by x plus 1 in brackets. It's an important part, and again, it's a mistake that a lot of people make, so just be careful. Right, from here, again, we're just trying to find out what a, b, and c are equal to. So we're just substituting in numbers for x to eliminate the letters, or eliminate part of the brackets, so that we can solve to find the rest. Okay, so to find b and c, we have to eliminate the other one carefully. Okay, so to find a, what we're going to do is we're going to let x equal to minus 1. If we let x equal to minus 1, it actually gets rid of the b and the c. Okay, by making this bracket equal to 0, b and the c disappear, in which case we're just left with a, in which case it's nice and easy to solve. Just take your time. This is where a lot of you have been making mistakes with your negatives, just you're substituting in. This is the easy part, but because obviously it's easy, you're trying to rush it and you're just making mistakes. So just take your time at this stage. Okay. But again, if x equals minus 1, we've got minus 1 squared, which is 1 times by 3, which is 3. 2 times by minus 1 is minus 2. So we add that to the 3, which gives us 1, plus the 1 is 2. Okay, on this side, minus 1 squared is 1. Plus 2 minus 1 is minus 1, plus 2 is positive 1, times by a is just a. A is 2. Nice and straightforward for the first one. Okay. Right, to find c though, got to be a little bit careful here. Okay, we're going to make the x equal to 0. By making x equal to 0, then the b disappears, but the c doesn't. Okay, because it just makes b times by 0, which is just 0, but we still need to add the c, and we still need to multiply it by the x plus 1. So again, just be very careful here. Letting x equal to 0. On this side, we get 0 plus 0 plus 1, which is just 1. 0 plus 0 plus 2 gives us 2a. And then 0 plus c, which is c, times by 0 plus 1, which is 1, gives us c. Okay, so 1 equals 2a plus c. Now that we already know what a is, we can substitute that in to find us what c is. So 1 equals 4 plus c. However you choose to do it, there's a couple of little mistakes again creeping in terms of your basic solving equations in the first couple of parts. So just be careful here. Take away 4 from both sides. C equals minus 3. Okay. And then for the final part, it's kind of up to you. You can't substitute in 0, but what we can do is we can just substitute in any arbitrary constant, make it as basic as we can. So just pick 1. Obviously, if you substitute in one that you've already found, it's going to make it have an issue there. So think about this first. But 1 is left. We haven't used 1 already. Substitute that in and just get a nice straightforward equation, and then substitute in the values that we've already found. You're going to have a, b, and c at this point. There's very little choice there. But because you know what a, and c are, you can work out what b is. Okay. So just working that through, and again, you can see I've taken my time here. Okay, I've used a few steps and found out that b is equal to 1. So you do the same. Okay, take your time, make sure you get the correct answer. Okay, now you get a bit of sexy PowerPointness here. Whoa. Okay, so using those values, we're substituting them back into what we did at the start, and just be careful. It's the a that's over the x plus 1, and just deal with this accordingly. Okay, so it's 2 over x plus 1 plus 1 times by x, so you can just write it as x, and then plus the c, so plus minus 3 is just x minus 3. Okay, right, on that note, in terms of the last couple of things, of situations that we've had, you've ended up with the numerator, so one of these values basically as a fraction. Okay, just some of you are doing really well with dealing with that. Some of you just substitute it in. That's okay to a degree, but it won't be okay in a final exam. They want you to simplify it as much as you can. So just think, if say a was equal to half, you'd have a half over x plus 1. We don't like writing it like that. That's not the simplest form. So just think of it as a half divided by x plus 1, and then just think how you divide fractions. You flip the second one, multiply it, so it's a half times by 1 over x plus 1, in which case it becomes 1 over 2 times by x plus 1. So just simplify it a little bit more for me if you can. And yeah, that's irreducible quadratic factors on the denominator.